Hello guys, my name is Felix from examsconnect.com. Welcome to our physics class. It's a continuation of measurement, what we had started with. Now we continue with uncertainty and errors. So in the case of uncertainties and errors, I first want to define some two terms. The first one is true value. What do we mean by true value? And the second one is accuracy. So when you talk of the true value, we are talking of the ideal value that can be gotten by ideal measurement. So this one is gotten by ideal measurement. So this means that it is not possible to get an actual due to the errors that are available. We might not get the real ideal. It is a sort of fictional value. However, we can get an accurate answer. And how do we define an accurate measure? Now, an accurate value or measure, it is the closest value. This is the closest value to the ideal value. An accurate value is the closest value to the ideal value. Meaning that even if we cannot get this fictional value, if I may use the word, we can get a value which is closer to the ideal value, and that value is what we call the accurate value. Let me give an example. Now when you're taking the temperature from a thermometer, we can have that as our reading. Maybe we can have this as 25, 26, 24, and 23. All this in degrees Celsius. So when you are calculating the temperature from this thermometer, we can say that the true value might not necessarily be 25. So we can say the true value is around 25.2, roughly 25.2. However, this cannot be gotten from an analog machine. Therefore, we try to look for the accurate one, the one which is closest to 25.2. Therefore, 25 now becomes our accurate value. So we have the true value and the accurate value. So from the reading, we can only get an accurate value that is closer to the true value, since we are working with an analog type of a device. So when you're talking of uncertainty, we now define what is uncertainty. Consider this. So consider this example that I had given, the 25 degrees Celsius. So the range that the temperature is going to be within is 25 degrees Celsius plus or minus 0.5. We can get our absolute error as this. And I'm going to explain later how we find the absolute error. And you can say this, that from the absolute error, you can now get what we call relative uncertainty, also known as fractional uncertainty, relative uncertainty or fractional uncertainty. So how do we calculate the fractional uncertainty? Now, fractional uncertainty is gotten by absolute error, where I take the absolute error 0.5, you divide it against the accurate value that you had gotten, 25. That gives us our fractional uncertainty as 0.02. We have started with absolute error, and from the absolute error, we have gotten relative uncertainty, also known as fractional uncertainty. We can still go further and calculate percentage uncertainty. How do we calculate the percentage uncertainty? We now take the relative uncertainty, 0.02, and multiply by 100%. Therefore, we get that for this value that we had recorded from the thermometer, our percentage uncertainty is 20 I'm at 2%. Our percentage uncertainty is 2%. Now, from that, I think we are through with uncertainty. However, I had said that I'm going to explain where we get the absolute error from. The absolute error is gotten from a half of the smallest place value of your accurate value. So if my accurate value was 25, I take the lowest place value, that is ones. Ones can be recorded as just a 1 times a half. So that I can get this as 0.5. So 0.5, or the absolute error, is gotten by a half of the smallest place value. Maybe I can give another example just to explain more. So consider this. The following values were taken from a sample. The first one is A, 25 centimeters, B, 17.3 centimeters. Then you are told, can you record the absolute value? Remember that with the absolute value, you can be able to get the relative uncertainty and also the percentage uncertainty. Therefore, for the first case, I take the ones as the lowest place value in this case, and I multiply it by a half. That's the same as saying 1 times a half, giving me 0.5 as my absolute value, absolute error in this case. For the second part, the smallest place value is a tenth. Therefore, it can be represented as 0.1 times a half, giving me the absolute value or the absolute error as 0.05. Therefore, you can always get the absolute error of any value that you are given by multiplying the smallest place value times a half. Finally, I can give another example. Calculate the absolute uncertainty. I want to give an example that relates directly to what I've just done. So you're told to calculate the absolute uncertainty of a meter rule. Example. Calculate the relative or the absolute uncertainty of a meter rule. Calculate the absolute uncertainty of a meter rule. In the solution, we first come and look for the accuracy. Remember, we defined accuracy, the accuracy as the smallest measure that can be done or can be handled by an instrument. Therefore, for the case of a meter rule, the smallest unit that can be measured, is 1 centimeter. Therefore, we can get our absolute uncertainty as 1 centimeter times a half, or 0.01 meter. Remember that the SI unit of length is meter times a half. Therefore, we now get our answer as 0.005 meters or 0.5 centimeters. And remember, with this, you can now get the relative uncertainty and also the percentage uncertainty where required. Next, we go to another term, precision. Remember that we are still under measurement. We have looked at uncertainty and errors, so we go to precision. A precise measure can be defined as a measure that shows very little spread around the mean average value. And I'm going to give an example for more understanding of what we mean by a precise value. Now, look at this example. After some sample was taken, the following were the outcomes: 20 units, 24 units, and 22 units. From that sample size, can we find the precise measure? We first calculate the average. We want to calculate the precise measure of this sample size, 20, 24, and 22. We first begin by calculating the average. The average is equals to the average of 20, 24, and 22. The average is 22 units. I am using the word units because we are not given the value, whether they are in centimeters, kgs, so I just use value. Therefore, we have defined the precise measure as the measure that has very little spread around the mean average value. Therefore, if this is my average, I can define 22, which is among the sample size, as the closest to my average. Therefore, it becomes a precise measure. It becomes a precise measure. And that's how you calculate the precise measure when you're given a sample size. So I think with that, we can stop at that part. Thank you for watching.